Good holy everyone. Today I am going to discuss my topic about learners with intellectual disabilities particular to the condition of dyscalculia. What is dyscalculia? Dyscalculia is a specific learning disorder with impairment in mathematics which is associated with significant difficulty understanding numbers and working with mathematical concepts. So the child in the picture shows the improper placement of operational symbol of addition and is one of a common indicator of a learner with dyscalculia. So what are the causes of dyscalculia? According to dyscalculia.org and Esmeralda Zerafa, a master degree of education at the University of Malta, specializing in responding to students' diversity, there are three significant roots of dyscalculia, and these are the physiology of mathematical functioning, genetic and social factors, and the scholastic factor. So first is the physiology of mathematical functioning. When we say physiology, it means that study of how human body works. So human brain have two hemispheres. These are the right and the left hemisphere. So the right contributes the ability to perceive shapes, remember musical phrases, and recognize face. Number two is the left hemisphere, which controls the specialization in speech, sequential tasks involved in reading, and numerical tasks. So in the picture, brains of children with dyscalculia and typical children are compared. Cushion et al. 2006 note that during tasks involving exact calculations, both children with and without dyscalculia have the same level of brain activation. However, if task requires approximate calculations, smaller area of the brain seems to be activated for learners with dyscalculia. Second is the genetic and the social factor. So genetics also influence different developments of acquiring mathematical skills. As with all disabilities, math aptitude can be inherited or an inborn disposition. So family histories of mathematically gifted and retarded individuals revealed common aptitudes in other family members. Another factor is the scholastic factor. Teaching style reflects teachers' own learning style. Teachers need to realize that if students experience difficulty, they should consider the following questions. Is my teaching style excluding students with certain learning style? Are the methods materials I am using compatible with the student's cognitive level and learning styles? Has the student mastered requisite skills and concepts? Teachers should contemplate and address these issues, or else student might come and tell us, how do you know that I have a learning disability? It might be you that have a teaching disability. I guess nobody would like that to happen. So let's proceed to the signs of dyscalculia. There are so many signs of dyscalculia, yet I have only indicated some of these. So for preschool and primary school learners, they have trouble learning to count, struggles to connect a number to an object, struggles to recognize patterns like smallest to largest. They have difficulty learning and recalling basic number facts. They use as fingers to count instead of using more advanced strategies like mental maths, and poor understanding of the signs and symbols of addition, subtraction, multiplication, and division, or may confuse these mathematical symbols. For the secondary learners, struggles to understand information and charts and graphs, struggles to learn and understand reasoning methods and multi-step calculation procedures, has trouble measuring items like ingredients in a simple recipe or liquids in a bottle, has trouble applying maths concepts to money, such as calculating the exact change. And for adults, difficulty counting backwards, difficulty remembering basic facts, slow to perform calculations, weak mental arithmetic skills, a poor sense of numbers and estimation, difficulty in understanding place value, addition is often the default operation, and high levels of mathematics anxiety. How do teachers assess learners with dyscalculia? So this is according to Michelson 2007. First is the norm reference testing. General standardized testing is one way dyscalculia may be identified. Shaliv and Ross-Trur 2001 indicate that such tests assess children's mathematical attainment in relation to their age. Standardized testing can be carried out quite easily, as such tests may be administered by educators in the classroom. I have here an example of a part of the standardized test used by Esmeralda Zerafa for Charmaine a student suspected with dyscalculia. So Charmaine is 10 years and 3 months upon actual date of assessment, and she was not yet conversant in symbols and language related to the 4 basic operations. So she performed at the 5th percentile, which means that her output is just equivalent to 8 years old. Instead of using multiplication and subtraction, she added the numbers instead. So another way of identifying dyscalculia is by observing learners over several occasions. So from such observations, one should be able to determine whether learners are experiencing any dyscalculic tendencies. So provided here is an identification checklist where teachers utilized in observing a child endowed with dyscalculia. It is divided into 3 categories, which are the personal issues, numbers and the number system, and calculations. Last is the dyscalculia screener. Dyscalculia screener, or DS for short, is a computer-based standardized test designed to diagnose dyscalculia in children aged 6 to 14 years and to distinguish this condition from other issues that can affect performance in mathematics, such as difficulties in communication and interaction, behavioral, emotional, and social development. It is a user-friendly and uses tasks to determine pupils' proficiency in basic numeracy. It is administered on an individual basis, and each test takes about 30 minutes per child. So the diagnosis of dyscalculia is based on the 49 results of 4 different tasks. The speed is also considered upon its completion. So these are the activities in the dyscalculia screener. So all these tasks deals with numericity, and thus it helps find out if a child is dyscalculic or not. And here is an example of the output or the dyscalculia screener report. It says here that the pupil has low performance in the 2 capacity test and has guessed the answers of the achievement test. This pattern of results is evidence of dyscalculia. Now let us proceed to the suitable intervention for children with dyscalculia. So these are the 3 important phases of an intervention program: the assessment, the intervention, and evaluation. So assessment is crucial as it will determine the strengths and the barriers to their learning of mathematics. The second process is the actual intervention. It entails having one-on-one sessions with the child in order to target their specific difficulties. Adaptations should be made to the class environment and to the teaching styles and methods. In Zarafa's study, her main intervention is the catch-up numeracy program, in which she conducted 20 sessions with the child and make formative assessments through various activities. She uses multi-sensory techniques or learning numbers using senses. In here, a child might count 3 balls so that she can see what 3 actually looks like, or she might clap or ring a bell 3 times while counting to sustain learning. Constant evaluation of the interventions being put to practice is essential if one is to determine which strategies are working with the child and which are not. The last part presents the results of a student, Charmaine, scored in the standardized test before the intervention program, and her achievement in the same test after the program was carried out. So this result demonstrates that with proper intervention strategies, learners with dyscalculia can make enormous advances towards their learning. Thank you and good luck.